Welcome to Julia for Talented Amateurs, where I make wholesome Julia tutorials for talented amateurs everywhere. I'm your host, the Dabbling Doggo.
I dabble.
Last week, we learned about control flow, specifically the concepts of conditionals and loops. Today, we'll learn about functions. In Julia, functions are the principal building blocks of programs. You've already seen a lot of built-in functions that Julia provides for you. In fact, your very first line of code, Hello World, makes use of the built-in function println. After today, you'll be able to create your own functions to help you perform some amazing things. Conceptually, what are functions? Functions are mechanisms to achieve abstraction and decomposition. In computing, abstraction means hiding unnecessary complexity from a user so that the user can focus on using your product and/or service without actually having to know how it works. For example, a user doesn't need to know how to build a drone in order to use a drone. A function is like an individual drone. A user doesn't need to know how it works in order to use it. Think of a function as a black box. For example, println is a built-in function. You don't need to know how it works in order to use it to print Hello World. As a user, you can just use it. This is what is meant by abstraction. In computing, decomposition means breaking down a large, unmanageable problem into smaller, manageable pieces that are easier to understand and to solve. A common goal can be achieved by many different pieces working together. Continuing with the drone example, rather than creating one massively large program, a programmer can utilize many different functions working together in order to achieve a common goal. This is what is meant by decomposition. Abstraction and decomposition can be very powerful together. Functions are reusable blocks of code. Functions are not run in a program until they are called or invoked in a program. Here are some of the characteristics of a function. A function has a name followed by parentheses. The convention is to use lowercase names, like variables. The function has 0 or more arguments. A function has documentation. This is optional, but it is recommended. A function has a body. A function returns something. When creating functions, you need to wear two hats. One as a programmer, in order to create a function that works, and two as a user who is looking for functions that are helpful and easy. You've already seen several built-in functions, like println, typeof, varinfo. Previously, we have been using the begin-end format to enter blocks of code. However, it's difficult to reuse that code. Creating functions will allow you and anyone else to easily reuse that code. Let's jump into Atom to see how to create functions. Functions are constructed using a function end block. Let's take a look at an example. The block is made up of two parts. One, a header, which includes the function name immediately followed by parentheses. And two, a body, which contains the code to be executed. Like naming variables, when naming functions, the convention is to select an easy-to-remember name, all in lowercase. The only difference between a variable name and a function name is that a function name is immediately followed by parentheses. The contents within the parentheses are called arguments. Julia is very flexible when it comes to the number of arguments within the parentheses. Depending on your needs, you may have 0 arguments, 1 argument, multiple arguments separated by commas, or you can have an open-ended number of arguments. In addition to the formal function constructor, there's a second way to construct a function, which is similar in syntax to assigning a variable. This is the same function that we just created, except using a compact assignment form. This is visually similar to assigning a variable to an expression. The only difference is that the name is immediately followed by parentheses. Let's take a look at some code that you've already seen in previous tutorials. Doing so will 1. Reinforce material that you've already learned, and 2. Demonstrate how easy it is to convert code that you already know into a function. Here's an example from the basic math tutorial. The original code was simply using the multiplication operator. Let's create a function called myMult that multiplies two numbers together. In order to call the function, simply type in the name of the function, immediately followed by parentheses. and enter the arguments to be used in the function. Look at the workspace panel for myMult. Notice that the icon for myMult is new. That's the lowercase Greek letter lambda. Here's an example about booleans. The original code was simply using the greater than sign. Let's create a function called isGreaterThan that checks if a number is greater than some other number. Again, in order to call the function, simply type in the name of the function immediately followed by parentheses, and enter the arguments within the parentheses. Simple, right? Let's take a look at some control flow examples from the last tutorial. Before we begin, type in exit to start a new Julia session. Here's an example of a conditional. The original code compared two numbers and had three branches to execute depending on the result of the booleans. Let's convert this conditional into a function called myConditional. As you can see, the body of the function is exactly the same as the code that you've already seen. The only difference is that the code is included within the function end format. Let's call our new function. Here's an example of a while loop. The original code used a global variable I as the loop counter. Let's see how we handle that using a function. Let's create a function called myWhileLoop that will allow a user to select the upper limit of when to stop printing. Notice that both the variable I and the conditional loop are within the body of the function. All of the code within the body of the function is in the local scope of that function, so there's no need to set up a counter in the global scope, and no need to call out to the global scope from within the body of the loop. Notice in the workspace panel, there is no variable I listed, just your function named myWhileLoop. Placing the counter and the while loop within the body of the function solves the problem of having to use an external counter in the global scope. Let's call our new function to see how it works. Here are some examples of for loops. The original code used the range 1 to 10 as the iterator and printed all of them out. Let's create a function called myForLoop1 to allow a user to select the number of when to stop printing. Note that you can use any name as the argument name. Let's call our new function to see how it works. Now, what if we wanted to let the user select a starting point other than 1, in addition to selecting the stopping point? Let's create a function called myForLoop2 that allows the user to enter both a starting number and a stopping number. Let's call our new function to see how it works. What happened to that last one? Everything seemed to be going so well. In order to count down, we need to include a step number to tell Julia to count down by -1. Let's create a new function called myForLoop3 to allow the user to enter a starting number, a stopping number, and an optional step number. If the user doesn't enter a value for the step, the function will select 1 as the default value. Notice that the optional argument is separated by a semicolon and the default value is entered like a variable assignment. That last part is called a keyword argument and is abbreviated in the Julia documentation as KWARG. Let's call our new function to see if that fixed the issue. Pretty slick. Let's take a look at some data structures to see how we can use functions to make it easier for users to navigate. Start a new session of Julia by typing in exit. Let's start by setting up some data structures. Let's create a function that will allow a user to iterate over the contents of any dictionary. Let's create a function that will allow a user to iterate over the contents of any tuple, array, or string. Pretty cool, right? Hopefully you're beginning to see the power of creating functions. The user of the function doesn't need to know how the function works in order to use it. All they need to know is what it does and what arguments to include. The function does the rest. Let's take a look at constructing a dictionary and an array using a function. In the original code, we set up an empty dictionary, ran a for loop, and then typed in the name of the dictionary to get it to print out. Now let's take the exact same code and put it into a function block and let the user select how big they want their dictionary to be. Notice that we use the keyword return here. Put a pin in that for now. I will discuss the keyword return in more detail in a few minutes. Now let's do something similar for an array. In the original code, we set up an empty array, ran a for loop to push values into that array, and then typed in the name of the array to get it to print out. Let's use the same code and let the user select how big they want their array to be. Looks great. Type in exit to start a new Julia session. Remember FizzBuzz from last week? Let's turn FizzBuzz into a function and let the user select how many times to count. Easy, right? Finally, let's take a look at a for loop with a nested for loop. In the original code, we initialized the variables x and y and set up an array filled with zeros. Then we ran a for loop with a nested for loop to construct an addition table. Finally, we typed in the name of the array in order to get it to print out. Let's create a function that will allow a user to create an addition table with any number of rows or columns. Pretty amazing, right? Something interesting about functions is that without the parentheses, a function object may be passed around like any other value. Let's take a look at println, typeof, and var_info. These are three built-in functions that we have used in previous tutorials. Let's say we don't want to type all that in. You can simply assign println to p, typeof to t, and var_info to v. Now p, t, and v should work just like println, typeof, and var_info. Pretty wild, huh? By the way, var_info is an example of a function with 0 arguments. Let's start a new Julia session by typing in exit. What is the keyword return, and how is it different than println? Let's take a look at an example. On the surface, add return and add println appear to be the same, since they both printed 5. However, let's try binding the values to a variable. D returns nothing. Look at the workspace. D has a value of nothing. So what happened? The keyword return, quite literally, returns the value of the expression back to the caller. In this case, it returned the value 5 to the caller, which was the variable assignment operator, which allowed the value 5 to bind to the variable c. In the case of add println, all this function did was print the value of a plus b to your terminal. It did not return the value of a plus b to anyone. So the value of a plus b was used locally within the body of the function and then discarded. Since the function addPrintln did not return a value, the variable d was bound to a value of nothing. So the lesson here is if you want your function to return something for use outside of the function, use the keyword return. If you merely want the function to display something on the terminal, but not to use outside of the function, then use the println function. When returning values, functions don't have to return a single value. Here's an example of a function that returns a tuple. This function divides two numbers and returns the quotient and the remainder as a tuple. What if you want to create a function, but allow different users to select different numbers of arguments? No problem, Julie's got you covered. Julie allows for the use of an arbitrary number of arguments by using the ... operator. We used the ... operator before when we unpacked the contents of a tuple. Back then, we called it the splat operator because we were taking one tuple and converting it into multiple values. In Julia, when you go the other way around, in other words, take multiple values or arguments and convert them into one argument, that process is called slurping. However, it uses the same ... operator, which can be confusing. Here's an example of a function that prints a shopping list based on the arguments entered, without knowing the number of arguments beforehand. That could come in handy when creating new functions. Type in exit to start a new Julia session. Type in question mark to bring up the help prompt. Enter println and hit enter. The text that comes up is called Markdown. When you create a new function, you can include your own custom Markdown text as well. Here's how to do that. Use the begin-end block to enter multiple lines of code. Create a function called is_even. However, immediately before starting the function end block, enter triple quotes. The text entered here will be read by Julia as markdown text, and will be used as the description of this function. Those are backticks around the true and the false, not apostrophes. The backtick key is in the top left corner of your keyboard, left of the number 1 key. Those are triple backticks before JL_docTest. JL_docTest is the keyword that displays the text within the triple backticks, like it would appear on a REPL screen. You close out of the markdown text with another set of triple quotes, and then construct your function as normal. Let's make sure that the function works. Looks good. In order to see your markdown text, type in question mark to bring up the help prompt. Now type in is_even. And you should see our markdown text. Looks professional, right? Search for is_even in the documentation panel. Your markdown text is the first entry. Click on the 3 dots to expand the view. Looks amazing. Notice that there's an existing function called isEven, without the underscore, with very similar markdown text. But yours is much better, since you wrote it yourself. Well, that's it for now. Today, we learned all about functions. We learned about the concepts behind functions, and then we looked at a lot of different examples so we could learn how to create our own custom functions. Despite the awesome power of functions, remember that functions are just wrappers for code that you already know how to write. Believe it or not, you already know a lot, and in just a few tutorials. Next week, we'll learn about multiple dispatch and how to create custom data types. If you enjoyed this video and you feel like you learned something new, please give it a thumbs up. For more wholesome Julia tutorials, please be sure to subscribe and hit that bell. If you have any questions, please post them in the comments below. Feel free to spread the word by sharing this video, since I'm sure you'll all agree that this is the finest tutorial on all of YouTube.
Worst tutorial ever.